Do you want to reduce the startup and warm-up time of your Java applications from minutes to milliseconds? In this video, we will explore 4 approaches to making your Java services start up faster or even almost instantly. Any application uses classes for its work. And all these application classes and core JVM classes must be loaded and initialized at application start. But this process repeats with every startup. So the idea behind application class data sharing, or AppCDS, is to avoid repeating this process every time the application starts, but to load a set of system classes and application classes once and store this data in an archive. This archive is then used as a read-only metadata by the JVM. Reading the archive is faster than loading the classes from scratch, so the startup is faster. In addition, multiple JVM processes can use the same archive. With AppCDS, you can achieve about 40% better startup. And if you use Spring Boot, you can enable ahead-of-time processing, and the application startup will be faster by more than 50%. The key advantage of AppCDS is that it enables tangible startup improvement without the need for code refactoring. Project Layden is an OpenJDK project under development. The project is focused on shifting some computations and optimizations from runtime to some earlier stages, for instance training runs. Then the application will use precompiled code and classes during the production run, and so the startup will be faster. Project Layden uses AppCDS ahead-of-time compilation and other techniques of shifting computations that will enable a reuse of transformed code without breaking the compatibility with the Java platform specification. But Java is a very dynamic language. It won't allow shifting computations randomly. So the project team will work towards introducing permitted constraints to the Java platform specification. They will be weaker than closed-world constraints, where more applications can use them. The goal is to introduce full closed-world constraint in the future. Early access builds of Project Layden are already available. I have tried them out with a Spring Boot application and got 3 times faster startup. So we are looking towards production-ready builds. GraalVM native image is the technology that uses ahead-of-time compilation to perform static analysis and convert Java bytecode into machine code at build time. As a result, a Java app is turned into a fully compiled native executable. A single executable contains the pre-initialized necessary application classes, required library classes, and statically linked code from the JDK. The key advantages of GraalVM native image are very rapid startup in 1 second or less and immediate peak performance without warm-up. One consideration when using GraalVM native image, you have to provide a metadata about all cases of dynamic features used in your application in a special config file, or else the native executable may behave unexpectedly or crash during the production run. Coordinated Restore Checkpoint, or CRAC for short, is an OpenJDK project. It enables you to create an image of a running and warmed-up Java service, save it to the file, replicate this file among cloud instances, and then restore the application from the file from the moment it was paused, like a video game. This way, the application starts in several milliseconds and at peak performance. And the JIT compiler is still there, so dynamic performance optimizations are still possible. Some considerations when using CRAC. The technology preserves almost the exact state of a Java application, so the snapshot may contain sensitive data. Also, CRAC is a novel technology and it is not subject to TCK testing yet. I encourage you to try all these solutions with your application and see which fits best. You can find links to the relevant guides in the description box below.